All right, so in 12.8, we are going to be dealing with different translations of trig graphs. We've done stretches, kind of left, right, and up, down. Now we're going to be dealing with translations. And translations are going to be movement, some sort of shift in the graph. And we're going to talk about two different types: horizontal shifts, which move you left and right, and then next will come vertical shifts, where your graph moves up and down. So we are starting with these horizontal translations, and the name that we give these is the phase shift. So whenever you hear about the phase shift, it's how many units your graph is going to move either to the left or to the right based on just the normal cycle that you see a sine or cosine graph going through. So if we see here, the way that the graph will look is you will see inside parentheses, you'll have theta minus h. Okay, so notice it is minus, so just like with everything else, when you're in parentheses like that, it does the opposite of what it looks like it's going to do. So this, see how it says plus 20? That actually means you're moving to the left 20 degrees rather than to the right. All right, so let me show you this. We've got two different things right here. So this is just a sine graph. It obviously could be a sine graph or a cosine graph, but just to give you an example, see how this is a theta minus h, but then it says h is greater than 0. So if you have theta minus a positive value there, the shift ends up being h units to the right. Okay, so if theta is positive, or sorry, if h is positive, so that's the important part there, is that you end up going h units to the right. So you can see your original sine graph is the solid line here, and then it got shifted h units to the right. So that dashed line is whatever shift is happening here. So like this is h units right there. And then here, if h is negative, then you end up moving h units to the left. So this would come out as theta minus a negative number, which would really look like a plus, of course, when you see the graph. So this would end up moving h units to the left. So it's always the opposite of what you think it's going to do. And so we can figure out what that's going to be based on what you see inside the parentheses. All right, so when we are graphing these phase shifts, we still want to come up with the same values that we came up in the previous set of notes. We still want the amplitude, we still want the period, and then we're going to move the phase shift. So if we start with the amplitude is going to be whatever number you see out front here. So our amplitude is 2 units. So that means instead of going up to a high point of 1 and a low point of -1, it's going to go up to a high point of 2 and then down to a low point of -2. So it kind of stretches out that whole graph. And then the period, remember, is going to be 360 divided by whatever value you have right here, and we don't have a value there, so we're left to assume that it's 1. That means our graph goes through one complete cycle in 360 degrees. So that means the period is just the original period, which is 360. And then the phase shift. Phase shift is going to be the opposite of the number that you see in parentheses there. Okay, so our phase shift is -20, which means we're moving 20 units to the left. Okay, so that's everything that's changing based on what our original sine graph looked like, okay? So let's write down all of the things that we had before. And you're starting off in a very similar way as the way that we graphed these before. So you can start with, we're going to mark up the axis. And when we mark up the axis, we're going to start with the y-axis. And so we know how high and how low our graph is going to get. Okay, so mark up the axis. Okay, so we're going to go up to 2, down to -2, so that's the value of our amplitude that we use to mark up here. And then what I want you to do is write down kind of normally what our period would give us. Like it would start at 0, and then it would end at 360, and then I had you breaking up the pieces in the middle. So the middle would be 180, and then you cut those in half. We'd be at 90 and 270. Okay, so this is originally what I would use to mark up that axis if I didn't have a phase shift, but I do have a phase shift. So let's apply it, and what's going to happen is everything's going to subtract 20 units. So we're going to move them all 20 units to the left. So 0 moves to -20, 90 moves to 70, 180 moves left to 160, subtract 20 here, we're left with 250, and with our last value, it leaves us at 340. So all I did was I subtracted 20 from what every single one of those values were, and then I'm going to mark that on my axis here. Okay, so if we go a little bit to the left, so this is going to be -20 degrees, and then we can just kind of scale from there and just make sure everything's spaced out appropriately. All right, so that's negative 20. The negative or positive 70 would be like there, maybe. And then 160, maybe there. 250, and then we might want to take this just a touch farther and make this 360. Okay, so make sure they're all kind of spaced out evenly like that. They should all still be 90 degrees apart. Or I'm sorry, this should be 340, not 360. So they're still all 90 degrees apart. Everything just got shifted. Instead of going from 0 to 360, we shifted it to the left 20 units like that. So now last thing to do is we are going to do our sine pattern. And remember the pattern for sine, it starts on the midline, goes up to its high point, back to the midline, down to its low point, and then finishes at the midline. Okay, so our starting point is going to be at negative 20 instead of at 0, and it starts on the midline, which is right here. And then point number 2 is going to be at the high point, and since we have an amplitude change, like a vertical stretch, we know it's going to go up 2 units. Point 3 is back on the midline. Point 4 is down at the low point, and our graph finishes off at the midline. Okay, so instead of, like I said, going from 0 to 360, we shift everything 20 units to the left and it starts over there. So make sure you're graphing it as if our graph continues beyond just what we've plotted. Shouldn't just stop once our cycle ends. So arrows on both sides, make sure it shows that you're going through. Okay, so that is one example of just a horizontal translation. Okay, now we're going to take a look at the vertical translations. Okay, so vertical translations, of course, vertical means up and down. And remember, when something's outside parentheses like that, it does exactly what it looks like it's going to do. So when k is positive and you have plus k, you're going k units up. Okay, so k units up if k is positive, and then of course k units down if k is negative. So even though this formula here says plus k, if k is negative, it's going to be like plus a negative, which would come out like subtraction. Okay, so those are our shifts, moving up and down. And so we have this thing that we call the midline. Normally, the midline just ran right through this axis right here, the horizontal axis. But if our whole graph shifts up a certain number of units, then this value right here becomes our new midline, and that runs right through the center of the graph instead of this axis running right through the center of the graph. So that's what we call this midline here. All right, it's kind of the basis. That's when we say like midpoint, high point, low point, whatever. This is where the midpoint is going to be because we shifted the entire graph up however many units, or perhaps down however many units. Okay, so this one, we've got a new graph that we want to look at. We are going to state all of these things right here: amplitude, period, vertical shift, and then we have the equation for the midline. So we have our amplitude, and amplitude is just going to be the number that you see out front, either in front of the word cosine or sine, and so this would be 1/2 of a unit. Period, our formula is 360 degrees divided by b, and b is the number that you have in front of the theta. We don't have anything in front of the theta, so that just means that our graph goes through one complete cycle in 360 degrees, which means that's the period. And we have two more things here. We have our vertical shifts. Vertical shift either goes up and down, and it does exactly what it looks like it's going to do. So that means we go up 3 units. So a vertical shift of positive 3 means we're going up. And then the new equation for the midline. All right, so the midline, see how this is a y equals equation? Y equals equations are always horizontal lines. So for us, it's going to be y equals 3. So we start by plotting the midline. All right, so let's kind of put everything together. So remember, we use our amplitude to mark up this axis right here, the y-axis. So if we have 1 unit up and 1 unit down, halfway through would be that 1/2, the value of the amplitude that we're looking for. There was no phase shift here. We're, on the next example, we're going to combine both the vertical shift and the phase shift, but for here there isn't one, so it still just goes from 0 to 360. So we can mark that up. Okay, so we are going to mark the ending being 360. The start, of course, is 0. Halfway through the cycle would be 180 degrees, and then we can split those halves in half. So 90 degrees, and this would be 270 degrees. Do your best to make them even. That's going to make the graph look really good and really accurate. Okay, so next thing, this entire graph is getting shifted up to y equals 3. So I didn't leave myself quite enough space here, so let's actually change some things. Let's make this 1, this 2, and then we can shift this up to 3. Okay, so we're going to make that 3. So what I want you guys doing every time you have a midline, I want you sketching it in as if it's a little just dotted horizontal line here. Okay, and then if we make this 4, so our amplitude just takes us up half a unit and down half a unit. Okay, so from 3, it's just going to go up half a unit, down half a unit. It's going to be a really, really narrow sort of graph. Okay, so this is a cosine graph, and the cosine pattern, it starts at its high point, then goes down to the midline, down to the low point, back to the midline, and then back up to the high point. Okay, so those are the 5 points that we're going to plot. So starting at our high point, everything got shifted up 3 units, and then it went up half a unit from the amplitude, right there. Point number 2 occurs at 90, and it's going to be right on the midline, which is right here. Point number 3 is at the low point, which everything got shifted up 3 units, and then we go down half a unit because of the amplitude. Point 4 is on the midline, so it's going to be right here, and then point 5 ends up back at the high point. So really, really narrow graph. So remember, you're taking your arrows a little bit farther than the actual graph goes. So this is like barely showing any movement or activity here, and that's just because the amplitude is so narrow. So let's run through what these 2 values right here do for us. Half of a unit means instead of going up a full unit and down a full unit from the midline, it's only going up a half a unit and going down a half a unit. So remember, that's the amplitude is like the height of one of these little waves that you see on the graph, and it only goes up and down half a unit. And then the next thing that we see is this +3, which means instead of kind of centering around this line right here, the axis, everything got shifted up 3 units. Okay, so that is what a vertical translation looks like. Okay, here I'm going to lay out some steps to graphing trig equations, because then in our last examples we're going to combine everything up all together, and we're going to do vertical shift and phase shift in one problem, as well as the amplitude and the period change. Okay, so I want to make sure you have an outline, a step-by-step for exactly what you're supposed to be doing. Okay, so step 1, we want to find the value of the vertical shifts. Okay, and that's really easy to spot. It's just this value k that's hanging on the end. So this value right here or this value right here. You could even do tangent if we wanted to, which we didn't really do a ton of exposure to that. And then you want to graph in your midline. Okay, and the midline is just going to be that dotted line that your entire graph hovers around. So you're going to figure out where the vertical shift is, graph in that midline. That's step 1. Okay, step 2, find the value of the amplitude. Amplitude is also super easy to spot. It is just the value A. So right in front of the word sine or right in front of the word cosine, that's how you find your amplitude. And then you're going to use this to label in what your y-axis should be. Okay, so label up the y-axis. So just like we did at this example, we knew the midline was 3, and then it went up half a unit, down half a unit. So we labeled all those values on there. Okay, so you're going to label on the y-axis. While you're at it, let's label in what the maximum point is and the minimum point is using a combination of your midline and your amplitude. Okay, next step, we're going to start plotting out the theta axis now. Okay, so now find the period. We actually have a formula for this one. It's not quite as easy to spot. So we do 360 degrees divided by b. And b is this number in front of the theta. So it's after the sine or cosine, but it's in front of the theta. And then we're going to determine our 5-point pattern for theta. So let me show you what I mean by that. So we determine our 5-point pattern for theta. So previous video here, we did this. We knew for this example that our period was going to be 360. So this is what I mean by determining the 5-point pattern for theta. We start from the beginning, go to the end, cut it in half, and then split those halves in half. That's what I mean by the 5-point pattern. Okay, step 4, we're then going to shift that 5-point pattern once we figure out what our phase shift is going to be. So we find the phase shift, which is h in the formula. And remember, it's always the opposite of what it looks like it's going to be. And then translate that 5-point pattern. So just like we did in that previous example that I was just pointing out to you, with that one we subtracted 20 degrees from the entire 5-point pattern. So that's what we do. We either shift things left or right by moving those angles. And then 5, plot either the sine or cosine graph. So they each have their own pattern. Remember, sine goes middle, high, middle, low, middle. Cosine goes high, middle, low, middle, high. So plot whatever that graph is. All right, so let's look at an example here. This one I have every single value on there, and we're gonna throw in a little curveball with the radians. Okay, so amplitude, period, phase shift, and vertical shift. List all this out. So amplitude is the value right in front here, so 3. That means from wherever our midline is, we're gonna go up 3 units, down 3 units. That's how tall the graph will be. Period, we have a formula for that. Period is 360 divided by b, and b is 2. There's a 2 there in front of the theta. So that means our graph goes through 2 full cycles every 360 degrees, meaning it takes 180 degrees to go through one cycle. Next is the phase shifts. Phase shift is how far left and right your graph is going to go. So it's minus. So that actually means we have a positive phase shift. We're going to go pi over 2 units to the right. And then our vertical shift comes off of this number on the end, and it does do what it looks like it's going to do. So our vertical shift is 4 units up. All right, so those are all the changes that we're going to have. Let's go through the step-by-step that we have. So first thing that I told you guys to do is plot the midline. All right, so our midline is 4 units up, and then we go 3 units from there. So we're actually going to pretty much just cover just this positive version of the axis here. All right, so we're going to go up 1, 2, 3, 4 units, and we can plot in the midline there. Okay, that was step 1 that I just wrote for you guys on that previous page. Step 2 was to find the amplitude, which we did, 3 units. Use that to label on the y-axis. Okay, so from this midline, I can go up 1, 2, 3. So this is the maximum value that my graph will ever hit. And then from the midline, again, I can go down 1, 2, 3. So that is the minimum value that my graph will hit. Okay, so this is 1, this is 7, our midline is 4. We can have that all labeled down there if you'd like to. Step 2, figure out the period, which we did. It's 180 degrees. And we want to figure out what our 5-point pattern would be for theta. So this is given in degrees. This is given in radians. Since the function's given in radians, you want to make sure it all matches. So this would be pi. Pi is exactly the same as what 180 degrees would be. So let's label on what our 5-point pattern would be. So normally we would start at 0, end the cycle at pi. So let's start cutting these things in half. So halfway through that cycle would be pi over 2. And then if we cut those in half, so between 0 and 1/2 would be 1/4. So this would be pi over 4. And then between 1/2 and 1 would be 3/4. So this is 3 pi over 4. Right, I know the radians are a little weird. You could always feel free to use a unit circle to kind of walk you through where these points are coming from. Okay, but we're going to shift everything. We're going to go pi over 2 to the right, so we're going to add pi over 2 to everything. So 0 plus pi over 2 would, of course, be pi over 2. Pi over 4 plus pi over 2, like 1/4 plus 1/2 would be 3/4. So that's 3 pi over 2. Pi over 2 plus pi over 2, 1/2 plus 1/2 would be 1, or 1 pi. This is already 3 pi over 4, and if we add 1/2, so 3/4 plus 1/2 would be 1 1/4, which is 5/4. And finally, if I take 1 and I add 1/2, I would get 1 1/2, which is 3 pi over 2. Okay, so just to keep everything equally spaced, these are all pi over 4 apart. So I'm going to start with pi over 4. And then the next one would be pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2. Okay, so those are all 1/4 of a unit apart. So I translated my 5-point pattern using the phase shift. That was step 4. And now I'm going to plot the sine or cosine graph. So I know that it is a sine graph. So the sine graph starts on the midline, goes to its high point, back to the midline, low point, and then finishes the cycle at the midline. Okay, so my starting point right here is pi over 2. So at pi over 2, I start on the midline, which would be a point right there. Then point 2, 3 pi over 4, I go up to the high point. So I already labeled on there where my max would be. So it'd be right there. Point 3 is pi, back to the midline, right there. Point 4, 5 pi over 4, we are down to the low point, which I just marked on here. It's the minimum value. And I finish my cycle off back at the midline. So I go right here, finish off a point. So remember, the cycle existed before we started graphing this one, and the graph will continue to go on after. So make sure that you are drawing arrows and showing that this graph is periodic and will keep going even outside of this one cycle that we draw. So arrows everywhere, and it would just repeat the same pattern over and over and over again. All right, so that's what that one looks like. Last thing we're gonna do is create an equation for ourselves here. So the height of water in a wave pool oscillates between a maximum of 10 feet and a minimum of 6 feet. Okay, a wave generator pumps 3 waves per minute. Write a sine function that represents the height of water and then graph the function. Okay, so if the max is 10 feet and the minimum is 6 feet, what we want to do is figure out what's halfway in between there, and then we would have the minimum. So like here, we had a max of 7 and a minimum of 1. So you could figure out that halfway in between would be 4. So that would be the midline. So max 10, min 6. The midline would be 8. And so we know that that's K. In our equation, for sure, that's going to be K. Like here, this is 4. That's K in the equation here. So we got that. Took care of this information. Wave generator pumps 3 waves per minute. Okay, so every minute has 60 seconds. 3 waves per minute means the waves are coming every 20 seconds. Okay, so the period is 20 seconds. And remember, what we want to do with that is it should have been 360 divided by B. So we can solve for 20 that way, or we can solve for B that way to figure out what would have gone into our equation. All right, so what I'm going to do is multiply both sides by B just to get it out of the denominator. So now I have 20 times B equals 360. And to get B by itself, I divide both sides by 20. So this ends up being 18. B is equal to 18. What that means is I go through 18 cycles every 360 degrees. And I guess it would be 360 minutes or whatever if we're doing it in terms of T. That's our normal cycle. All right, let's finish off the rest of this. So I've got, this is a period change. This is a height change. That's a vertical shift. I also would have an amplitude. So my amplitude, from 8, I go up to 10, down to 6. That would give me an amplitude of 2, and that would be A in my equation. So let's write a sine function, so we know that for sure. So my sine function starts off as A times the sine of B times theta minus H plus K. So the values that I do have, I can plug those right in. So I have Y equals, I figured out my amplitude was 2. They told me it's supposed to be a sine function. I figured out B would be 18. Never said anything about a phase shift left or right, so I'm just going to ignore that H. And then my midline is 8, so I can do plus 8 like that. So this kind of all stays together right here. There's nothing in parentheses. So now I'm going to graph it, and it'll look like this. Okay, so I know it's going up to 10, down to 6, so leave myself plenty of space down here. So I can go 2, 4, 6, 8, 10. Keep going. My midline is 8, so that would be right here. Amplitude is 2, so I know when I go up to 10, that's my maximum value. Oops, I guess I scaled it by 2, sorry. When I go up to 10, that would be my max value. Down to 6 would be my minimum value. So this is 10 and 8 and 6. And then I know I adjusted my period, so I'm going to go through a full cycle every 20 seconds. All right, so we can do something like this. So every 20 seconds, I'll go through a full cycle. So if I make this T for time, I can make this 20 seconds for a full cycle and then start splitting this in half. So a half cycle would be 10 seconds, a quarter cycle would be 5 seconds, and 3/4 the way through would be 15 seconds. So I know it's a sine graph. It's the last little thing. Sine graph goes middle, high, middle, low, middle. So let me sketch that in. So the midline is 8. So it starts here, right on the midline, then up to the high point. 0.3 is back on the midline. 0.4 is down at the low point, and then I finish the cycle on the midline. So this we go like this, kind of curves around. You can see our wave, and it's just going to keep repeating itself from that point on. This one's weird. It's a story problem, so I actually don't extend it off to the left here because this is T for time, so I can't possibly have negative time. The wave generator starts right here at T equals 0, and then it goes on forever off to the right. All right, pretty sure, yes, that is all I have for you for 12/8.